Okay, I'm going to try to help you out with some of the things on the sheet today. Just try to power through as best you can, and if there's stuff you still don't get, we'll try to talk about it tomorrow. Anyway, so the first one, if I'm writing from exponential to log form, it's log. Remember, the little number is the base, so that's 5. The number on the inside is the result, 125, equals the exponent, 3. So 5 to the third is 125. So we can do it again over here. Log, the little number is the base, so 1/4. The inside number is the result, equals the exponent. All right, so if you just keep that pattern down, then changing them over is not too bad. Write the following expressions in terms of logs x, y, and z. This is actually asking you to expand the two. So in doing that, I did a couple that would be a little bit more messed up for you, so you could at least get an idea. All these roots we have to change to powers first. So in this one, we've got log of x to the 1/2. And then here we get y squared, and notice there's a cube out there, so it's a cubed root. So instead of 1/2, that would be to the 1/3, which we're going to have to deal with a little bit more in a second. And then that's all over z to the 4th. Okay, so now let's fix this y cubed. The exponents rules are multiplying, so there's a lot of things that are going to be going on in some of these problems. So this will become log x to the 1/2, y to the 2/3 over z to the 4th. And now we can use all the log rules that we learned yesterday. So we get 1/2 log x plus 2/3 log y minus, forgot the exponent, minus 4 log z. All right, so the second one, we have another thing to clean up. So it's log, and here that 4th root. So instead of 1/2 or 1/3, now this will be 1/4. So we've got the log of, and in this case they're all inside the root, so they all get affected. So now let's use the exponent rule, which says that this would be x to the 3/4, y to the 2/4 or 1/2, all over z to the 4/4 or just 1. And now we can break this up again using log rules, and so that would be 3/4 x plus 1/2 y minus, forgot the logs, 3/4 log x plus 1/2 log y minus log z. Okay, so then as if you're looking, you see this ln that's there. Ln is a special type of log. First of all, its name is the natural log. And it gets its name because ln, at least this is where I think it gets its name, is equal to the regular log base e. And we talked about e. E appears in nature everywhere, so I feel that's where it got its name, natural log. And so since e appears so much when you're doing mathematics, that it got its own special name, so you wouldn't have to keep writing log base e. So anytime you see ln, it's just log base e, and you could use it any way that you would use any other log with any other base. Okay? So here, if we're solving the following log equations, for the ln one, we can just write in the e, and then it's just e to the 4th power equals x. And so on your calculator, well, you already know about the e buttons. So e to the 4th would just be 54.598. All right, the second log ones, again, unless there's something fancy going on, just use the definition of log. So remember that's base 10. So let's set up the equation. 10 to the 3rd power equals 4x plus 1. Well, 10 to the 3rd is 1,000. Subtract 1 from both sides. And then divide by 4. So x equals 249.75. Okay, and now we get to this, and this looks a little nastier, along with the one below it, but here's where we have to use the log rules we did yesterday to come up with the answers to the problem. So we know that if we have addition between logs, we can put them back together by multiplying. So log of x times x plus 2, when I contract them back together, would equal to the log of 9x. That still looks kind of iffy on how to solve it. However, if you notice that both sides we have the exact same thing. We have this log function. And so on one side, it's saying that this is the log of x plus 2. On the other side, it's saying it's equal to the log of 9x. So that must mean then that x times x plus 2 has to be equal to 9x. If I'm doing the same thing on both sides, then the thing that is on the inside of it must be the same. All right, so now we can just solve this out. More reminders. X squared plus 2x equals 9x. I have a quadratic, so I want things equal to 0. So subtract 9x. So x squared minus 7x equals 0. And now you could use quadratic formula. If you recognize it, factoring is really easy in this case. Take out a GCF of x. And then the two answers here, this side will be 0 when x is 0, and this side will be 0 when x is 7. And so those are my two answers to that problem. This one's a little bit more complicated because I do not have a log on the 12, so I can't use that same property where the two sides would have to be equal to each other. But I still do have to start with the same idea of contracting the two logs. So that's going to be one big log equals 12. Okay. And so now at this point, oh shoot, sorry. I copied down, or well, I think I was trying to make up a new problem and I wrote this wrong. It's not going to work nicely. The idea would be that you would take, you would just do the log rules at this point. And so we would get 4 to the 12th equals, and then multiply it out, x squared plus 3x minus x is plus 2x, and then minus 3, except that 4 to the 12th is going to be humongous, and it won't fit nicely. So I guess we could do it, but that's the idea behind this type of problem. When you see it, that's what they want you to do. So sorry about that. I'll have to show you further when I come back. Two more things left to look at, I think. Yep, two more things left to look at. Number 9, 5x plus 3 equals 13x. The thing that's weird about this one is if you try to do what we would normally do and do log base 5 on the left-hand side, the problem is we'd have log base 5 on the right, and that's a 13. So in this case, and again, you can use this in any cases, because of that exponent rule, any log will technically work if you're trying to solve an equation that looks like this. So let's just use log base 10 for a couple reasons. One, we don't have to write an extra base. And two, everybody has a log base 10 key on their calculator. So the exponents now are going to pop out. So we get x plus 3 times log 5 equals x times log 13. All right, and then we can just find log 5 and log 13 and do the necessary math behind it. So log base 5 log base 10 of 5 is 0.699. And log base 10 of 13 is 1.114. And now we have a regular equation, albeit with some ugly decimals. So I get 0.699x plus 2.097, I just distributed, equals 1.114x. And now we do some subtracting. 2097 equals 0.415x. Divide both sides by 0.415. And we're left with x being equal to 5.053. All right. And here's the last one. Given that log 5 equals x, express log 500 in terms of x. So we want to get rid of the log. You see some problems like this on here. And the idea is now we have these log rules for multiplying and dividing and exponents. So I want to find a way to write 500 in ways that I won't need the log anymore. And so in this case, since it's log base 10, I can take advantage of that and say 500 would be equivalent to 100 times 5. And now with the log rules, that would be log 100 plus log 5. And I know what log base 10 100 is. That would be 2 plus, and then they tell me from the problem, log 5 is x. And so that's 2 plus x. Good luck today. I know that some of it is going to be challenging. Stick with it, see what you can do with it, and we will talk about it tomorrow. Have a good day, everybody.